are the PyLadies Amsterdam team. People from different backgrounds, but with one common goal, to share and spread the love of Python. It's Nancy Irisara Mendes from the left, Bhumika Agarwal from the right, and me, Alyona Galyeva, in the middle. We are a team of PyLadies Amsterdam. We are a local chapter of global nonprofit PyLadies, officially recognized by Python Software Foundation in November 2019. And what we're actually doing, every month we deliver in Python coding workshops, tailored to different topics, but usually we try to keep up only with one specific theme or topic and cover it, or as a beginner or more advanced level. And from time to time, we do joint events with other communities, Python communities mostly. And on top of it, we also do bootcamps from time to time. So yeah, if you want to know more about where to find us, here you can find all necessary information about us. All links are clickable, and this presentation will be shared in the GitHub repo as well. In a nutshell, the website is umbrella for everything that happens at PyLadies Amsterdam chapter. We always share all materials from our workshops and talks, so that's why there is a link to our GitHub repository, our YouTube channel, where we store all records of streaming sessions and previous recorded sessions. All events are usually posted on the Meetup, and all updates could be followed or via LinkedIn or via Twitter or via both, whatever works for you. There we always post something about specific tickets available, diversity tickets for different conferences, so stay tuned. And now I would like to introduce to you, as I mentioned, our partner in crime, Dexter, and I would like to welcome on stage Inge, and she will tell you more about the company she's working at and the awesome use case that they prepared for you. Inge?
Thank you. I will share my screen now.
Yeah.
Do you see my screen?
Yep. I do hope.
Hi, everyone. I'm Inge van den Ende. I work at Dexter. And I'm pretty excited to present the case here and to contribute to this PyLadies Machine Learning Engineering Bootcamp, because we work a lot with Python at Dexter, so it's a really good fit for us. I will first tell you more about Dexter, what it is, what we do as a company, and then I will talk about the case you're going to work on. It's a case about a problem that we're actually at this moment facing with the whole world in the energy transition. So I hope you're going to enjoy working on this case. So at Dexter, we really aim to be part of the energy transition to, with forecasting renewable energy, help to move from old fossil-fueled energies to new renewable energies. And that's two-parted, because the better you forecast them, the more profitable renewable energy will become, and then can compete with the old fossil fuel energy. And next to that, also in an electricity system, in the grid, always the same amount of energy has to go into the grid as it goes out. And the better you forecast what goes in and goes out, the better you can match them. And if it doesn't match, it's often very polluting solutions that last minute has to solve it. So by doing better forecasts, by using machine learning models, we can really help to prevent these solutions. And that's also something you will see in the case. And we do this in multiple services. So we do load forecasting, so really predicting how much a wind turbine or a solar panel is going to produce. Also flex asset optimization, so think about batteries, but also electric vehicles. Maybe you can charge them at moments that's good to balance the electricity grid. And also portfolio optimization, so not only predicting how much you're going to produce, but also helping how you can sell your energy. And we're a very new company. It's still a startup. It was only founded in 2016. So back then it was only one person. Currently we're around 20 people. So it's quite exciting that we're growing so much. And at Dexter, we really combine cloud technology, machine learning engineering, and energy domain knowledge to really bring them together and have the best forecast possible for renewable energy. And that it's a startup and that it's such a new company also illustrates how it is to work at Dexter, because it's a super young team. It's a dynamic working environment. Personally, I super much enjoy working at Dexter because we have a cool team, but also work on challenging problems, and everyone is very motivated to contribute to the energy transition. So that's a good combination for me. And if you have any questions about working at Dexter, feel free to contact us at any moment. The website's on the slide, and you can also find it in the case and just ask all your questions. So that brings us to the case you're going to work on. And as I already mentioned, this case is really something that we're facing with the whole world at this moment, because we have to move from an old way of thinking about energy to a new way of thinking about energy. The old way is that you're still working with fossil fuels. So you have coal or you have gas, and that you can easily say, okay, tomorrow I'm going to produce a bit more, or tomorrow I'm going to produce a bit less. So because that was the system, everyone used to think about, okay, how much energy are we going to consume? Let's adjust to that. So really start with consumption and then adjust your production. However, the new approach is not like that anymore, because with new energy generation, with solar panels or wind turbines, the energy is produced when there's wind, when there's sun, and not when you actually want to put on your dishwasher necessarily. So the new approach really is thinking, okay, how much energy are we gonna generate? And how can we adjust our consumptions, or are there other flexible solutions, for example, with batteries that we can use to solve this? And this is really something that's, it's quite difficult because it's changing at quite a fast rate. And also with batteries or other flexible solutions, they just do not have enough capacity to solve the whole problem. So we really have to change our consumption to use electricity at the moments that it's there. And that is what your case is about. Next slide. And of course, you're not going to work on the whole world, but you're going to work on a case about Pytown. Pytown, in this case, is a village in the north of the Netherlands. It's a pretty cool town because they want to become fully self-sufficient with their energy. So they want to use 100% renewable energy that they produce themselves. So actually, they did a super awesome thing because they built enough solar panel and wind turbines to produce the amount of energy they need. So they are already self-sufficient. So that was a super cool step. Only, let me now hide my camera for a moment because I see I'm in front of the slide. They are having some problems because they notice that the energy generation is not at the moment they actually use it. So often they use the energy when it's not there, which is of course not possible. So it's giving a lot of blackouts, and then it needs to be solved. So there's no energy for a while, and everyone in Pytown is getting very annoyed. And they really want to solve this because how it's working now, they cannot work with it anymore. But they already spent all of their investment in those solar panels and wind turbines, so they cannot easily buy a big battery. So the only solution they still have is to adjust their energy demand, so their energy consumption, to the generation, so that really people get a message with, oh, I can use a lot of energy today, or I can use less energy today than I would normally do. And that's the question to you, to help them with that and actually be able to live their lives again without having no energy all the time. And in this case, let me go to the next slide. Yeah. So for that, it's really important that you match both the prediction for how much consumptions are going to be and how much generation there's going to be with their wind and their solar. And if they match, then it's all good to go. And in this case, you will receive actually the prediction for wind and solar from an external company, also in the case called Dexter. But you don't have any use of this if you don't have your own prediction for the demand. So you can tell the people that live in PyTown, or they can use more or less than they usually do. So really, you need a model for the demand and also to deploy it. So that's in this bootcamp, the challenge to you to help PyTown and be fully self-sufficient with our renewable energy. Good luck with the case. If there's any questions, just message me.
Cool. Thanks a lot. Let me take over. Okay. 1 second, and it takes a little bit more time than expected. Okay, cool. So thanks a lot, Inge, for this beautiful introduction. We experienced some small troubles in the beginning of starting our stream. So a piece of information was missing. That's why I'm going to repeat it once again. First of all, welcome everyone for this bootcamp, bringing machine learning model in production, that's built together with Dexter. So we just saw the presentation of Dexter and the presentation of the use case. And the agenda for today is to cover the 4 major topics. The first topic was just brief introduction about us, and that's probably the moment where you started watching the stream. Another part right now is dedicated to the bootcamp setup. Then we go to cover the theoretical part of MLOps today, and we round up with a home assignment. So that's the next steps. So who am I and why should you listen to me? I'm one of PyLadies Amsterdam organizer, and in my, let's say, everyday life, I have a full-time job. I'm working as a hands-on AI data engineer at LINKIT. And on my spare time, I'm organizing PyLadies Amsterdam events, mentoring different AI-powered startups, and recently was awarded with Microsoft AI MVP. And in my day-to-day life, I see a lot of companies struggling with actually getting the value from using machine learning. That's why we're going to spend approximately 4 weeks during the bootcamp to cover the most important topics that you should know about. So next parts will be dedicated to some specific topics about the bootcamp. If you're just watching this stream or rewatching it later, you have time to drink a glass of water now, because I cover the parts essential for the bootcamp participants. And the bootcamp participants that are those 58 happy, lucky people who passed our examination process. So they were applied and got enrolled. So they will get mentor support. They will be working 4 weeks doing specific home assignments, then 2.5 weeks on the capstone. If during this stream you have any questions, you can post them in the YouTube stream channel. Bhumika, my colleague from PyLadies Amsterdam, if it's something urgent, she will pick it up. If it can wait, then we can answer it later. But once again, today's part is pure theory, and the next streams will be more live coding with home assignments that will entail specific coding as well. So regarding schedule and learning materials, as I mentioned before, now we're in week 1. Then we'll have week 2, where we will cover the hands-on part for batch deployment based on our use case. The 3rd week will be dedicated to, let's say, mini batch near real-time deployment. And then we'll finalize with the best practices and preparation to the capstone. And the capstone will be the most difficult part of the whole bootcamp, where you're going to work together with your colleagues. All communication will take place on Slack. That's why we invited all of you to our Slack channel. If you experience any issues with Slack, you can always contact us via email. After this session, we will announce on Slack channel how this 58 people will be distributed among our 9 mentors. And then after this 4 week, we're gonna cover the capstone. As I mentioned before, it will be more difficult than the exercises and assignments you experience during the bootcamp. And after the capstone, you have time to present what you've done. So actually, from the team, you can pick up one person who's going to present this, your journey, your struggles, your challenges, how you overcome these challenges. And then the last piece of the bootcamp, the last piece of the puzzle will be a written feedback provided by mentors to the team's GitHub repositories. So to set, that exactly concludes the introductional part. And now we're going to switch to the most interesting part of it, and it's exactly machine learning operations part. Probably you heard a lot, MLOps, it's something about continuous deployment, it's something about operations. Actually, MLOps is even bigger than that. I found this nice picture that represents 3 common pieces that match good together, although if you look at this picture, it's still not just circles, but it's more like non-stopping communication between all of them, because one cannot exist without another one. So if you take a look on what exactly MLOps is, it's just a standardization or streamlining of so-called machine learning lifecycle management. What do we want? We want to make sure that everything we do could be reproducible, could be repeatable, and could be standardized in some of the ways. And actually, if you look at the companies, especially huge enterprises that have approximately 50 or even more machine learning models in production, then you know that it's a huge pain to do it in the right way. Because a lot of factors play a role, and while decided what we're gonna show and teach in this bootcamp, it was really hard to choose, should we cover all languages or should we only focus on Python? Should we cover all scenarios or should we focus on the specific ones? So imagine that there are so many different dependencies. There are so many languages that you can just think about. Traditionally, you heard, okay, probably the majority of the models or algorithms is written in Python, but we have completely different options. It could be in Java, it could be optimized for running with Spark. So there are a lot of various options, and it's really hard to glue all the pieces together. But our attention is not just glue pieces together, but to make sure that this is a robust system that works. And also what we learned so far, that it's pretty hard to find the software engineers with ML knowledge. There is a specific rule that data scientists are not software engineers. I agree and disagree with this statement at the same time. I agree because what I see that the focus and the beauty of the work of the data scientist is exactly doing science with data. And the beauty of software engineering is building robust and scalable systems that are going to support this data, or they're going to support the generation of the data, or processing the data, or generation of the insights. So to say it simply, there is no one way, no one specific standard how you can organize and deploy the models. And there are so many different use cases that a lot of companies understood we need to do something. We need to introduce a specific way of working, specific procedures that could help us to make our life easier and let us sleep during the nights instead of be woken up by alerts that something go down in production settings. And to describe what do you mean by machine learning lifecycle, let's take a look at its building blocks. Usually, MLOps building blocks are shown as a circle, and then you have arrow to arrow, so you're going from one stage to another, to another, to another. In real life, it's a little bit messier. We usually start literally with the understanding of the problem in hand. It never starts with, oh, let's just deploy this awesome state-of-art deep learning network that's going to do something. Nobody knows what. We usually start with what's the problem in hand. And if this problem could be somehow supported by data, that's where exactly this movement takes place. So we're starting from business understanding to the mapping of specific data sources that could be potentially used. So that's where we start with so-called exploratory data analysis. We need to understand what kind of data do we need. Let's take a look back at our use case. So we have a city or town, town, that wants to become self-sufficient, right? So the goal is not to have a sophisticated algorithm doing predictions. The end goal is to understand whether I'm able to charge my device and use electricity at my household tomorrow or today. That's the goal. So probably here we'll start with what the end user needs. The end user needs some alert system or a dashboard or a site that she or he can goes to, open, and get some useful information. So in this case, if we're talking about energy consumption, energy generation, we need to understand how can we get all this data. And if you want probably to model this scenario, if it's proved that it could be modeled, though, if we go to this point, then here we also need to understand what kind of extra data do we need. In majority of cases, while doing forecast, we're working with time series data. There is nothing more than just two columns. One column is timestamps, another column is specific value attached to it. So in case with energy demand, we have one column that specifies the timestamps, when the measurements were taken, and then we have the value, what is current demand for energy. If you look at, for example, wind generation, you have again time series. You have a timestamps saying this is specific frequency when it was when we measure it, and then you have the amount of wind energy available. The same story with solar energy. And if we want to do something, if we want to model it properly, and if we want to add probably extra features that will bring us to this part, we need to understand what kind of extra data do we need. If we need a temperature, how we can get this temperature. Is a specific RESTful API exist, like weather API in this region where we can call and it will supply the good information for us? Do we need something more? Or probably we want to know what amount of solar energy was, or let's say it another way, how much sun do we have today? Do they have a specific influence on our forecast? So where we can get this information from? And usually in the majority of the cases, while going from business understanding to the data analysis, there will be fast forward communication, because you will learn, okay, I need a temperature. Could I get this temperature? And then you learn probably you could get this temperature, but with not a frequency that you want to get. Or if you want to do the forecast, the amount of, for example, wind and solar energy generation, imagine that here, our data engineers or our team or software engineers team is saying to us that, sorry, we only can deliver this data once per week. And if I need a prediction for tomorrow, and I want to make sure that this prediction as robust as possible, what should I do? So going back to the start, starting from business understanding, what do we want to achieve? We go into the data to understand what kind of data is available, how we can get this data, how we can process the data, how we make sure that the data will arrive on time on a specific place where we can use it. And only after that, we are starting playing around with the modeling. Also, probably you would be surprised to hear that in the majority of cases, we're not starting with machine learning modeling immediately. Probably just statistical models will do the trick. That's it, nothing extra. You never know what could work for you in the case. It's usually good practice to start with some specific, stupid, and just basic, the most basic model as possible, to make sure that we can use this model with the data that we have. And as soon as we have something like a small working prototype of the model, we want to test on the real life data, we want to showcase somewhere on a dashboard or in any other way, that's where we start going back and forward again. And only after that, when we know that probably it sounds promising, and business leads give us a permission to move forward from this like small technical or business idea, proof of concept, then we are going to the next step. But if looking back at this picture, usually the biggest building blocks are start with specific business understanding, then iterate to understand what kind of data available, are this data good, are there some good quality, is the data in the amounts that we need, could we get this data at the ratio that we need with the specific frequency, then we'll see whether it's possible modeling or not. And also what's nice to say that in the majority of the cases, you don't need deep learning at all. In the majority of the cases, you can solve specific problems with simple linear regression, but with properly engineered features. That's where also the magic happens. And then based on the way how we go to deploy our model, usually preferable to do is in the way that it's not immediately from proof of concept directly to production, and you never tested the whole pipeline end to end from the data ingestion up to the predictions from the model to the end. The best way is to go step by step from proof of concept to small so-called MVP, most valuable product, just to test whether we can have what we want end to end. Imagine if we say we want to predict energy for tomorrow, and we want to be as sharp as possible, then you need to make sure that at least for this setup, you can have data available to build your own features. And if this data not available, what should we do next? Should we update our model? Should we remove these features, or what are the steps? And while doing all of this, what do we want to make sure that if we come to the point with a model training, we want to make sure that we log all these experiments as well, so we can get back to it, we document it. And then we're building, not doing everything manually, but building specific pipelines that help us to deploy these models further. So to sum up all that I said before, we have these building blocks, but still we suffer from a lot of common challenges. And what are these challenges? The biggest challenges so far, it's actually data quality. Probably heard this, garbage in, garbage out. Yes, and that's what happened with machine learning, and not just with machine learning, but with anything related to the data world, again and again and again. So how accurate your data are? Are there any errors in your data? Do we have, for example, the data that are complete and consistent enough? If we're talking here about to make predictions, we need to get temperature for specific city. Do we capable of getting this data in a reliable manner? And can we rely on this data? The same story, I don't know if you're building like some specific recommender in the app, in the grocery app, you want to make sure that you're offering a product that doesn't have 2 million calories. So all this goes to the data quality. And timelines, I think, is the most important part, because if I need data to make any predictions, I want to make sure that the data delivered on time. And if I want to make predictions tomorrow, it means that I need to build my features, I need to have a specific data today. Or if I want to build probably something that will do forecast for next 15 minutes, I want to make sure that I have enough data points delivered to me on time to build this prediction. Reproducibility, I should say, it's one of the hardest problems so far. And lots of splits that you do with, for example, with scikit-learn, if you do something with TensorFlow, PyTorch, if you work with pandas, it's built on top of NumPy. So there are a lot of randomness that you can just get. If you don't fix your seed, there will be no way to reproduce the train test split again. There will be no way to reproduce the specific weights initialization. So reproducibility is one of the hardest problems, and that's why a lot of open source tools popping up that help you to make sure that everything that you do, you can log in and you can make sure that you can reproduce the results on different machine. And the joke that okay, it's not a joke, but it's a harsh reality. It works on my machine, and I don't understand why it doesn't work on yours. That's a huge story indeed. Then there is another concept. There is actually more concept here. It's not just data model drift. It's data drift, it's feature drift, it's a concept drift or model drift. And what is all about that your data will be changed over time. The question is how fast this change will happen. Will it be a slow change, or will it be the change, rapid change? Just to give an example, so when we're talking about data drift, we're talking about, let's say, the change in the data distributions during the specific period of time. And just to give an example, let's say COVID, any forecasting algorithms that were running that way, they just broke almost all algorithms because all buying patterns and everything was completely changed. An example of slow data drift, probably some new words happening, invented in the languages. So that's the good example. Or if we get back to COVID again, a good example of data drift will be if you're looking at the specific text corpus, then you see that starting from, at least in the Netherlands, from, let's say, December 2019, the specific words that pop up more often. Feature drift is exactly when the features that you build will probably not be, couldn't be built again because the specific data will not be in your data set again. So you literally can lose some specific features. And the model or a concept drift, it's about drift between the relationships of data and targets. And that's exactly the drift of the relationships. They're changing over time. So in this case, because of something changed, your target looks completely different. And all of that, we want to make sure that while we have our models deployed in the right way, we want to make sure that we perform a proper monitoring, but still there is no one way to do it. There are different options how you can approach it, different algorithms to use it, or just simply compare specific, for example, distributions and seeing what's happened. That's why it makes it so hard. And scale. Because we know that for specific models, train requires one type of infrastructure, but serving requires completely different type of infrastructure. At the same time, when we are working, for example, with time series, and you will see it further in the bootcamp, the biggest issue that as soon as we see new data points, we need to feed again. And for time series, we're going to work with backtesting, and it requires, again, a specific infrastructure setup. And the last but not least is actually its art of balancing different objectives. And what it's all about is about that you as a data scientist, you will be probably optimize your model for performance, and you will be taking a look at specific model performance metrics. So in case with regression, you're going to take a look at specific set of errors. In case with classifications, you're going to take a look for usually also specific set of metrics, but that's not the metrics that are point of interest for a software engineer, because this person will be more care about how fast they can get inference with the less CPU, for example. So there are different objectives, and for business people, probably they want to optimize for something different. So all in all, to say that we see that the whole building blocks are pretty huge, and each block requires a lot of effort, requires a lot of processes to be set to make sure that we can achieve qualitative data, reproducibility in what we do. We can handle the data feature and model drift. We can handle the scale if it's needed, and we are good at optimizing multiple objectives. So this is the most interesting question, because if you just Google how to deploy my model, the chances are pretty high that you will end up with, containerize, deploy with Flask, here you're ready to go. Yes and no. There are so many different scenarios. Probably you can even not imagine how many, and there is no way to cover all deployment scenarios in one go. So different scenarios will require different needs. So let's dive in the deployment scenarios. Before doing that, there is a huge, huge difference between machine learning for research and machine learning in production. And as you see here, there are completely different optimization goals. While you're working in research, while you're training or preparing or building or developing a new state-of-art algorithm, you usually work with a static data set that is called benchmark data set. It's nice, but unfortunately, the data that your model will see at your company in production every day will be completely different. And it could change really, really drastically and rapidly. Another point, fairness. It's also a pain point right now, because from one side, we have specific set of libraries, but there are some frameworks proposed to make sure that the algorithm you're using is fair. But we want to make sure that you understand what's in your data and what's happening with your data, because if somehow your algorithm will cause damage to the people, it's a really, really, really sad situation. Another point regarding interpretability is also take a lot of attention, because in case with research, of course, you want to get the good results, you want to get the state-of-art algorithm, the great one, and you want to make sure that you can interpret why these things happened. But from another side, if you want to do something, especially in the huge enterprise setting, literally you will be not allowed to deploy something that's impossible to interpret. So in this case, there should be some things added definitely to the workflow. Regarding performance, that's what I mentioned before. The idea is to have something in production that it's not awesome, but something that's good enough and just a little bit better than simpler models, and that's good. And in case with priority, that's exactly where the priority for production goes on. So we talking about we need fast inference, because the longer the inference, the more we need to pay for compute where this inference takes place on. And if it's something where actually end user is waiting for response, we don't want to lose our customer because this person waited too long. And by the way, regarding the state-of-art algorithms, I used to have a small story that happened to me a paar years ago. I was busy with proof of concept for a visual search app. So the idea was that you make a picture, and from this picture, it can show you something that looks like this, like similar. So for example, idea was to use it for a search using pictures, and probably it could be used by if you want to buy something and then you just look for something that look like this, or you want to travel to a specific place and you just want to find the place that looks like this. Idea was really nice. I came across the beautiful paper about the zero-shot learning and one-shot learning. It was the great models, great scenario. Idea was awesome. So I started preparing materials for a short demo for PyData events. And then I decided, okay, so I applied transfer learning. I need to retrain the latest layers. And then I learned by accident that if I want to retrain only 2 last layers of this model, I need to do it approximately 4 weeks on a Tesla GPUs. And I was like, oh, no, I'm not going to do this. So from one side, the idea looks really awesome, looks really nice. But if you want to apply it for production, imagine that you have an application in your hands. You don't want to wait as well that this monstrous model will run somewhere in the back and will give you a reply back in a pair of hours. So there was a problem just to train the thing, and I'm not taking about using it for inference because it was so big and so huge, but the idea was pretty awesome. So you see right now that there is a huge difference with approach to machine learning in research and in production. And it's mostly about specific rules, specific things that have to be done if you want to have something in production, and also the focus, the priorities. If you're just looking at the algorithm versus the algorithm that should be deployed. So, and I've thought about that. What are the scenarios? As I mentioned before, there are a lot of different scenarios how we're going to deploy it. In our case, in our use case, probably we will going to work with a dashboard. So imagine that we have a specific dashboard that could be opened or from a web browser, or it probably could be opened from the browser and the mobile phone, or in any other way. We will see how it will goes. And for these dashboards, I want to deliver the forecast, actually. So how am I going to do it? Which option to pick up? Let's take a quick pick on what's available and what's actually could be done. What kind of scenarios we should have. And as I mentioned, usually we start with what's the end goal and how this end goal should look like. Should it be an application? Should it be like something that runs somewhere just on the background and delivers results to somewhere? What kind of requirements do we have? And in case of requirements, we always speaking about latency. So actually, how long should you wait until you get your prediction back? Throughput, if we want to predict something in batch, how many things we could run simultaneously, so how much data could we handle, and other peculiarities of the hardware, network, and of course the cost to for the inference. Because if you have a great model, but to make an inference, you need to use GPU for it, and GPU instances cost some not sense, then probably for a specific company, it's not the right use case. So what we're going to focus on, we're going to focus briefly on server-side deployment, what it entails on a client-side deployment, and also really interesting approach, which also a point of my interest, a federated learning. But we'll cover it briefly today. And then during the bootcamp, we're going to work mostly on the server-side deployment. So let's take a look, what does it mean to have a server-side deployment? Let's take a look at this workflow. So imagine that we are the person who is living in this PyTown. So I want to understand whether I'm able to charge the devices in my household, for example, tomorrow. So probably I'm opening a dashboard, and probably this dashboard already has an information, or I want via dashboard get to know what's going to happen next 1 hour. Probably there's a button somewhere, so I click on this button and it generates prediction for me. So what's happened underneath at this moment? So the request is sent, the request is validated, that's yes, that's the right person, you can access, you can start the prediction process. Then we go what kind of data we need to make this prediction for you. Then there is a pre-processing of the data happens to, if there is features involved, to build these features, probably to clean some data, to check for outliers, something like this. Then this data goes into the model returns a prediction got to the post-processing, because probably just the 1-0, and you don't want to show the end user 1-0, you want to show user charge, don't charge, or you want to show something different. So that's where the post-processing is happening. And then is actually the result is sent. In our case, the result is sent probably on this dashboard. So imagine there is some search functionality probably in this dashboard. And if it's about search for historical time periods, it's not this scenario. But if it's about just getting the freshly data right now, probably it is. Another option, when you use, for example, Google Translate. So what you do, you copy a piece of a text, you put your text into the field. At this moment, there is a request sent to the model. The model performs all necessary transformation with this data to make sure that it's digestible by the model. The model returns a translation back, and you see end results sent. So you see this results on the screen. So that's natural what happens. Batch workflow is a little bit different. So what we're going to do here, we know that there are specific use cases when we don't need something just right now. So in case with our dashboards, we want to check or take a look at the historical data, for example. So probably we had old processes before that pre-computed all this, stored some places, and our dashboard just querying the data store to retrieve the data from there. So in our case, just imagine that we would work with the data points with a frequency of each 15 minutes. So imagine that I want to make predictions for next week. So what I can do in this case, probably I can use the batch workflow. So in this case, I gather all these data points together. I start in parallel the pre-processing of it. Then I'm gonna send it to the model. The model will run. The model will give outputs. I will post-process this outputs. Then I will store this result somewhere in the storage. And then, for example, if it's needed during the inference time, the dashboard could, for example, retrieve this batched pre-computed data for me and just give me the results back. So in the majority of the cases, actually, you're gonna work with batch. Usually, there are some specific processes that are running in the backgrounds where you not touch as a user. So there are some processes that do these predictions, then leveraging these predictions to a specific data store. And as a user, you exactly interact with this data store with a specific graphical user interface. So in the majority of the cases, everything will follow the batch scenario. And now, if we're talking about making predictions for a huge amount of data with a distributed processing, like frameworks such as Spark, we can leverage this computations pretty fast in comparison with many years ago when you need to wait a lot of time for it. So that's in a nutshell the server-side deployment. So in this case, if we're looking back, so we assuming that we have a model, and our model is running somewhere on a specific server. It could be a virtual machine. It could be a Docker container orchestrated by Kubernetes. It could be something different. And then we expose our model, for example, with a RESTful API, and then we got this response request scenario in, let's say, near real time. And it was a batch workflow. Probably there are some computations that's running every morning, and then I can just retrieve these predictions if I need them. And you should say, what about, okay, this is server side, so everything happens on the server. There is interaction with a model that happened in there. But what about if I want to have, for example, an app on my mobile phone? How should it work there? What if I want to do something where really latency sensitive, such as predictions for IoT devices, for sensor fusion, for self-driving cars, for example. There is no way to wait until you make a call to the model, there is some processing happens, the model returns result back. What if you need predictions instantly? What if you have something running on edge? In this case, we're talking actually about the client-side deployment. So for client-side deployment, usually what's happened, first, you train your model on a server. So once again, could be virtual machine or on any other compute scenarios. Then exactly you're saving your trained model, and then you package your model together with application. If we're talking about mobile app, then we'll have Apple app or Android app, or it could be something that could run on local device. It could be something, for example, like an edge device. Think about the camera that's running a simple classification algorithm, and then if it's needed, we passing the data further for more powerful models that are running on the server. But our goal here is to make sure that the inference is go as fast as possible and as smooth as possible, because your goal is not to drain the battery of a person if the person wants to use, for example, Google Translate. And in this case, probably one of the way to organize deployment of our energy consumption, energy demand model will be an app. But probably as we're starting right now, we're not going to build app immediately. We start just with a simple way to showcase the data, and it will be just a dashboard. So that's the example of a client-side deployment. Where you do everything, the training of the model that takes place on the server, and then you embed the model into the application. So it's like the part of it, and then you run the inferences locally and getting results locally. And now we came to this great concept of federated learning. The idea is really nice. So actually, it's built with a privacy in mind, in the data privacy it's data privacy by design. So in this case, you don't want to first collect all data in one place, train the model, and then just, let's say, do it as you do as a traditional machine learning. In this case, we allow not to train small models on each device based on the data that are not leaving these devices. And then we just pass in specific information that allow us to do the specific aggregation on server. But with this concept sounds really cool. There are a lot of limitations still. There are a lot of issues, but at least it's good to know that such use case exists. So to wrap up this part, what we learned so far, so there is definitely no one way to deploy the models. There are different scenarios based on specific needs. We have server-side deployments when everything happens on the specific server. We have a client-side deployments where, for example, we need to deploy something on edge or on a device such as a mobile phone or iPad. And there is also like this interesting mixed option of federated learning. So now probably you're curious, okay, I heard a lot of information. So I heard that probably MLOps is needed because it does something like it's some structure, processes. Then probably it's not the best idea to start immediately with training deep neural networks. We should start with the problem from the very beginning and just iteratively work for it. But now I have my model. So what then? So I have already the model. I tried different models. I decided that probably this model looks the best. What then? Where to go from it? And there are specific ways what to do. But in a nutshell, all the steps are going to the set of 3 major blocks. So let's discover these major blocks together. And also we'll see how we're going to use these blocks in our hands-on part in the lesson 2 and lesson 3. So we have a model. And before that, you heard that ideas, you have trained, you tested it locally, you know that it performs great. And then after that, you're just going back to the let's say the idea where it's gonna be deployed, and then you just a specific moment you have probably like a Python file, a score.py file, so you just load your model, you do predictions, and that's it. Yes, but there are some exceptions, and these exceptions you will see again during the lesson 2 and lesson 3, and these exceptions related to time series models. But it will be next week. So which steps we gonna follow? The step number 1. That step, sometimes it could be a part of proof of concept. Sometimes it's even bigger than proof of concept. But what we want to have here that we have some policies and rules. So if we decided to deploy a model, we need to know what's the end goal, how this model going to be deployed, and what kind of environments should be built to make sure that this model could be deployed smoothly. In traditional setup, you have dev environments, you have staging environment, acceptance testing environments, and you have a production environment. So the goal is that you use dev environment to develop new features, or do any different experiments, fixing bugs, whatever, and then you send it to the staging or testing environments where your colleagues, QA people help you to make sure that the piece of code that you delivered, it works, and then you pass it. After that, if it passes all tests, then you go or automatically or manually with a release manager to production. In case with machine learning, there are some caveats though, because the development is really iterative by nature. So now what's a lot of times happening, that development takes place not in development environments, but usually in so-called sandbox environments, where you have the possibility of experiments. But at the same time, while keeping this freedom of experimenting, you're using an open source tools, for example, such as MLflow, to log your experiments. So you can always get back and to see what are other good candidates probably for deployment were. Or if something goes wrong with your model, you know what to use, which model probably the best candidate to replace your model if you look back at the training runs. So when there is a decision taking that the proof of concept looks good, then where you're actually going from Jupyter notebooks, I'm not saying that everyone is developing in Jupyter notebooks, but the majority are, or Databricks notebooks or other types of notebooks, that's where you say, okay, now we know that it sounds more like MVP stage or pilot stage. So we need to set up everything configurable so we can reproduce everything that we've done before. So we started with configuring and setting up developments and test environments as well. And you will see later that actually your home assignment will be to start to set up your local development to make sure that it can do reproducible actions there. Then we want to make sure that everything that is needed out there. So usually when you work in a company, there is specific, let's say, departments responsible for specific pieces of infrastructure. If you're talking about on-prem, it could be like ops team that's responsible for also for provisioning specific resources if you needed it, if you need like extra server or something like this. If it's a cloud development, they're probably, the bigger the company are, the bigger the differentiation are, such as like a cloud excellence team. So they're responsible for letting you use specific services, yes or no. So at the moment when we decided to go in the direction of production, we usually start with a setup of infrastructure. So you know that probably I trained this model locally, and now I want to make sure I will want to run the last train. I want to make sure that this training of the model is, this run is reproducible. So I want to train it again. and make sure that it performs as good as it was, for example, on the local machine. And then what do we want? We want to make sure that we're not just thinking about only model, but about everything that surrounds this model as well. And remember that we're talking as soon as you get, before running any predictions, you get in data, right? And you need to pre-process this data to make sure that your model is capable of doing predictions on this data. And then you have a piece of post-processing as well. So in this case, a huge, huge piece of work is to make sure that there are specific data pipelines running and fetching data to you. And of course, that you have at least basic tests, software tests, and as well a model test. And what do you mean by that? Actually, it's you can start with unit testing, where you have a small piece of code just responsible for testing your small function, and then you evolve the whole test set to measuring actually the model, to capturing the model performance as well. So that's the phase number one. The decision is taken to bring a model to production. So you want to make sure that you have environments ready to start developing there. And then you have a specific framework in which you're following from one point to another, while thinking about the consistency, timeliness of data delivered that you needed to make the predictions with this model. And then there is just basics testing of the model, of its performance is in place. If it's ready, then we go into more transitions to operation. It's not production yet, but it's more like testing end-to-end what's happening. So in this case, what we are saying that there should be specific prerequisites and specific key tasks that we're going to fulfill. So as prerequisites, we want to make sure that if we have a model, we registered this model in the model registry. So there are some solutions out of the box with model registry, such as MLflow again, or Azure Machine Learning has the same model registry as MLflow. There are other options, or there are some custom built, somebody just using like a database or key value database for it. There are different options, but what do you want to make sure that if you pick up a model, either as a trained model, then you can register this model as an artifact, and your code has specific logging to make sure that you can evaluate the performance of your model, and you know what's happening during the, for example, during the specific steps in the process, what's happening on each specific step. And the most important information is here as well, documentation. And that's what's usually really, really neglected. I know that documentation is not the priority number one, but in case with machine learning, because there are a lot of moving pieces, we want to make sure that if it's model that is ready to go to production, we know how the features were engineered, why these features were chosen, which data sources were chosen for this. And if we have documentation for it, it usually helps in the future as well for debugging, for functionality, and for the rest. And that's where we rolling up our sleeves and we go in with so-called serialization or pack. So that's exactly a nutshell packaging of the model. So the idea is to pick up a model artifact. It could be a pickle file, a JSON file, or a Linux file, or other formats, and just to make sure that you can package it in container, or there are probably another way that you can somehow load this model and use for prediction. However, as I mentioned before, you will see some challenges that we will facing with time series models. Then we deciding which way the model will be served and which way, what it should be. Should be a RESTful API? Should it be, for example, a batch script? Or what should it be? And then we decided how we're going to orchestrate the process of actually model deployment from, for example, dev to acceptance, and from acceptance to production. So there are some specific automation in place. And of course, we want to make sure that we have some specific quality assurance guidelines, and we're going to follow these guidelines to make sure that everyone understands what's happened with this model. And the step number 3, that's exactly where the model is in production. The hardest part is there is no way to design all monitoring metrics and logging from the very beginning. So it's ongoing process. Although the model is already deployed in a production environment and returns prediction as requested, there will be some edge cases that probably you could never think about. So in this case, we want to make sure that our monitoring system that we're going to build is developing. And if we see that some metrics doesn't help us at all, we just throw away these metrics and we replace them with other. What usually works really, really well when you sit together with data scientists and other people involved in this process to brainstorm what kind of metrics are really, really important regarding just performance of the model, what kind of metrics really important for data scientists regarding specific model errors, specific model-related performance, and what kind of metrics are really important for business people. So if you look back at our energy use case, we're saying that's probably here what kind of metrics could be useful for us. We're talking about dashboards that are going to showcase whether they're capable of charging something or not. So what do we want to see here? And that's what we will need to design, because once again, unfortunately, there is no one ready-made set that you can immediately use and say, oh, I need this kind of metrics, I need this kind of, I'm going to log this, because probably you will learn that the library that you're using doesn't give the proper error, so the traceback doesn't help you to solve your challenge. There will be a lot of things where the things go wrong, trust me. And the huge question is, as soon as models in production, it degrades every day. It doesn't matter what you're doing, it will degrade. And the question is, when it's safe to understand that your model is actually degrading and to know where to retrain this model. But as we will see again in the future, there is so many things that can go wrong with time series models, and especially specific type of testing that is required is completely different from traditional models. That it's actually raised a lot of questions again. So usually there is no one answer, where should I retrain my model? There usually a sort of learning path to understand how the model is performed, what's happening there, and also to make sure that the model that goes into production is fair enough, it's not biased, and at least it doesn't make any damage to the people. And also what's nice to have here, because the bigger the company, let's say the bigger the way to solve a small problem, the longer the way to solve a small problem. So in this case, there should be some incident resolutions in place. So imagine that you have a monitoring system that monitors as a standard model performance, just like simple metrics. For example, you know that you're doing batch, so you're waiting for 20 files gets in, you're waiting for 20 predictions back, and then you see that something happens. But these predictions are really important because other models couldn't fire up without them. So what should happen then? Should it be an alerted system? What it should be? Should it be a pager duty? Should it be an email, a call? What it should be? And how, if something happens, how it could be solved? By restarting the instance, or what should be done? There should be some specific guidelines. And again, there is no one specific way to monitor specific types of model. That's why it comes with a little bit of learning curve to understand what exactly important, what's not. And also, that's what was about the model, machine learning model performance. And then you also monitor just the service telemetry. So you want to make sure that if it's RESTful API, and if you're probably there is some like load balancer in between, and if there is a lot of requests coming in, you can let's say scale up your resources, and if there are less requests coming up, you can let's say stop or kill some unnecessary resources, for example. Or imagine that you deploy something with in a serverless manner. Although it's serverless, there are still some servers there, and you have, for example, the cold start problem. So how you could handle this, or you see that some weird behavior happening. Probably you're under attack, your model under attack. So there are a lot of things that could be here. So for operations, when the model in production, we usually monitor on the performance of the model, including errors, the drift, data drift, feature drift, model drift, any inherent biases, any strange thing that's popping up, and also the telemetry, and as well the business people questions. But also what we have here as a part of it, as a data operations. Sometimes it could be a part of MLOps operations. Sometimes it's a separate, also depends on the size of the company and the roles. If you're the startup, probably you will be the person who will be handling end-to-end everything, literally. And if you're not, if you're a bigger company, there are probably people responsible, the data engineers that are going to deliver the data to a specific place. There will be data scientists that we going to do this. There will be machine learning engineers that are going to do that. But data operations play a huge role. Imagine that you're running a batch prediction service. So in this case, you're literally dependent on the data flows. And if the data were not delivered, or something wrong went with data, or the quality was bad, or actually your batch job failed because of that, then you need to know what to do, how to restart this data pipeline to make sure that you're receiving the correct data. So as you see, we started with MLOps as a way to streamline, standardize the model development, but now we see that with each step, there are more and more and more things coming on to the plate. That's why the whole word about MLOps, from one side, it sounds really complex. From another side, it's a really good attempt to somehow structure the underlying processes that we have. So what we're going to do during these weeks, we're going to pick up the use case. We're going to pick up the things that the data scientist team delivered to us, and then we're going to see what we can do to retrieve the specific data to make sure that our model could be deployed in a specific way. And while doing this, we are following specific best practices. The reason why we're doing it on clouds, because sometimes it's really nice to, let's say, not to reinvent the wheel and just use specific services that were already built for it. On top of it, there are also, let's say, the direction still into the movement to the cloud, because if the company wants to use machine learning and want to get the full functionality of it, you need to understand that probably your current infrastructure is not ready to support all these processes. Because imagine if you have a traditional monitoring system in place, traditional software way of doing things, and all company running in Java, for example, and then you are there with your Python model and nobody literally got a clue what to do with it. So what do we want to make sure that you will learn specific steps and how step by step in an iterative manner you can go from pretty messy Jupyter notebook to something that could be reproducible, reusable, and that will be deployed in the proper way. And we could set up some monitoring in place as well and reuse the functionality available in the cloud for us. And we're gonna take a deep dive into the world of Azure, and we're gonna work with specific tools from Azure, and especially we're gonna do some stuff in Azure machine learning, and you will see of zero eyes that it's not always straightforward sometimes. It will be a buggy way, definitely, but we'll go through it together, right? So that actually leads me to the home assignments. But before that, just to make a recap, what was discussed today, and then we will finalize with the assignment, and then we have probably time for questions. Probably there are a lot of, or there is no questions, we will see in a bit. So we started with introduction rounds, who we are as PyLadies Amsterdam, why we're doing this bootcamp. Then we moved to the beautiful story of our use case delivered by lovely Dexter and Inge. Thanks so much for that. Then we covered briefly the main topics related to the bootcamp. That's for those who are participants of the bootcamp. Then we discussed briefly the concept of MLOps. So there is a specific set of procedures to streamline and standardize the machine learning cycle. Then we took a quick look at the machine learning lifecycles blocks. That's where you start with the business question. So exactly why do you need to do something? What are you trying to solve? Then you move to an analysis part. Then you move into the modeling part. And during all these parts, you're gonna go backward, forward, because there will be something missing always, or not. Or the data doesn't look like expected to be, or something another is missing, or the data that you want to get, it's not possible to get with this frequency, or there's some huge gaps in the data, or there was that data were corrupted. You never know. And then from this part, we'll see how you can orchestrate and streamline some processes to make sure that you have reproducible models running in production. After these building blocks, we covered briefly different deployment scenarios. So there were natural, the two major ones, the server side and client side. And in this bootcamp, we're going to work with the server side deployment. So actually, we're going to use the compute from our own machines, but then for deployment, we're going to use the cloud compute. We're going to work with the smallest cluster to make sure that it's not incurs a lot of resources. And then from that moment, we're going to move to the point of the batch deployment, so where we're gonna wait and collect specific data points, aggregate them, and then make a prediction in it. Then we go to code near real-time scenario, where actually we want to predict something based on the freshly arrived data points immediately. So as soon as data points arrived, we want to generate predictions for it. There we learn and touch the concept of serverless. Then we move to this steps. So if you want to deploy a model to production, what does it mean for you? There are the huge 3 steps when you start with just configuring everything, making sure that you have infrastructure in place to do things that you want to do. Then moving to packaging your model, making sure that it's modular, and we have some documentation attached to it. And then moving to the points where it's approved by, for example, business people, and you go to the production setting where you will still experimenting a lot with the monitoring part, because usually in practice, it's almost impossible to set up it from the very beginning. Although you could have the similar use cases that looks alike, but still there will be some things that probably you don't expect to get. So that's what I be covered. And to conclude all of that, we have the first home assignments. It was a lot of information, I understand this, and this was only, let's say, one theoretical part of the bootcamp, and other parts will be more learning by doing and learning by doing together. We will be working in teams, 6-7 people. And will be guided by mentors. So the first home assignment, as I mentioned, it will be a setup. So via Slack channel, you can just go to this, or it's clickable as well. So from that, you got actually 2 home assignments. One assignment is to do a lot of installation. So trust me, there will be a lot of things to install. If you have something already installed, it's great. but still there are a lot of tools that we will need to move forwards. And another assignment is a little bit refresh your knowledge of working with time series. So that's where my proposal goes to go through the repo and watch the latest PyCon US talk about series with time series. And then go to explore a little bit awesome ASCII time library. It's a time series library compatible with sklearn, so they try to make your life as a machine learning engineer or a data scientist much more easier. And after that, there are some extra reading materials that you can cover as well. So we decided to have this introduction in this way to give a lot of information probably to you, and then let you to, let's say, to process this information, do a lot of installations, and then to refresh your knowledge about time series, and then get back to us next Wednesday at 6:30 at the Amsterdam time to make sure that you can actually continue with a live coding part. And that's on the lesson 2. In lesson 3, you will get home assignment that involves specific coding. So yes, that's it from my side. Bhumika, we have 8 minutes left. Do we have any questions, any concerns, any remarks that you want to share?
We have few questions, maybe 2-3 in the chat.
Yeah.
So one is, could we use the company's computer for bootcamp homeworks?
Could we use company's
computer for bootcamp homeworks?
Probably it's based on your company that you're working at, as far as if I understood the question correctly.
Okay, and
probably to I think if the person could be probably could formulate it a little bit different, then probably it will help, right?
Okay, we'll wait for her to reply.
Yeah.
We have 2 more slightly related questions.
Mm-hmm.
What do you mean by interpretability?
Mm-hmm.
And basically, since if interpretability is necessary for production, does that mean it is undesirable to use machine learning models in production?
Oh, I think it's a really great question.
Or deep learning models.
Oh, yeah. Yeah. Okay. So in this case, what do I mean by interpretability? That you understand how how the predictions were formulated by model. So in this case, there are different scenarios, different tools that you can use for that. I think probably the most popular is actually SHAP library. So where you can see immediately, for example, take a look at the features that you have, which features has more influence on the predictions. So that's one of them. There are more things to do to add to it. But what I'm trying to say about interpretability, that in this case, the business people who are responsible for, as the product owners, they understand how these predictions are generated. To make sure that there is no story that, we want to predict energy we want to predict like salary levels or something, and at the same time we have no clue how this is predicted. I'm not saying that I'm against deep neural network. No, there are a lot of beautiful tools for interpretability of these tools as well. One of my favorite is What If tool by TensorFlow. So there are even more to that. But what I'm trying to say that the reason why the deep neural networks getting less popularity in the enterprise settings, because of first costs of running inference with them, and second, because due to specific rules, company are not allowed to use something that it's not audited properly and create or generate some predictions in, let's say, unknown or understandable manner. Imagine the situation where you're going to have a surgery and you have a choice between a surgery that's gonna made by a person, and the person said, based on my experience of this many years, I did this, I did that, I have these consequences, and I'm gonna perform your surgery, but probably the outcome, the success will be 85%. Or you have let's say a person that says to you, I don't have a lot of experience, but this algorithm says to me, if I'm going to follow this, the probability will be 98%. What are you going to choose if it's your life? So that's what I'm trying to say. And once again, there are a lot of problems that, surprise, surprise, could be really solved by simple linear regression if you engineered your features properly. And especially in the field of forecast, for example, sometimes simple statistical models will do the job. And you know exactly, based on the specific distributions, specific attributes, why this decision were taken, instead of throwing it to a forecasting deep neural network where nobody actually knows how it's come out to the light actually. So I do hope that it explains.
I think it does. We had a request to repeat the name of the library.
Yes, the name of the library is SK-Time. So it's like S for Sierra, K for Kilo, SK-Time. And for those who are part of the bootcamp, this task, the home assignment, is in the GitHub repository. It'll be on Slack as well. So you will see the name of this library and the links to this library as well.
Okay. We have a few more questions coming in. Will we need Azure credits for this week's homework?
Yeah, we will definitely need some credits. That's why for those who applied for the bootcamp, we put a disclaimer that there is a possibility that the credits will not be provided. In this case, it's your responsibility to start a subscription. Everything that we're going to do could be pretty well covered by free credits that you receive. We're not going to run Hadoop clusters or train something on GPUs that will eat all resources in once. What we're going to do the smallest and tiniest, let's say, developments, and we're going to make sure that for batch, there will be pipeline that will start a cluster and that will kill the cluster. So there's nothing running on, and it's your resources. And for Azure functions, it's even simpler because you pay for what you use. So we're not going to run long compute processes. That's, again, eats a lot of resources. And we're going to do it in a light manner as well. I wish I could to show you everything, how to do everything in the most secure manner as possible with VNet, subnets, with private endpoints. But because it has cost with it, we're going to skip this part in this bootcamp.
Okay. And we have a very interesting question related to the use case.
Mm-hmm.
What are fairness points to consider in the energy-related data science?
Which points to consider? Sorry.
Fairness points.
Ooh, I think that's really a really interesting question. And there it depends on the data that we will work with. Because imagine if we want to do this and we know the zip codes of the homes of the people, and we know exactly which zip codes belongs to which parts of the city, and we should say something like, this is a poor people, we can just give them less energy, so let's assume that they can survive with it. They don't have a lot of electrical appliances. It will be okay, And for the people who has a car, 2 electric cars, I don't know, like a huge patio, probably with something, we say, oh, it's a nice zip code. It looks good. So let's give them more energy. So there is always something that could be, in the data sets. That's why the most important, I think, part being a data scientist is to understand your data and to understand how the data was sampled, how they were collected, and that you will see. Probably we will have the data that are completely anonymized without zip codes. Then probably there will be not too much things, but you will see it in a week.
Okay. And I think it's the last question for now. What about model predictions maintenance? For example, say the data scientist or ML engineer is no longer involved in the project. How to make sure the business still uses the model, and what are the best practices for this?
I love this question. And that's what should I say? That's the difference between good machine learning engineer and a bad machine learning engineer. If it was a good machine learning engineer, that it will give you everything that you as a data scientist can continue using, and you will understand why you're using this and why you're following these practices. And if it will be a bad machine learning engineer, sorry for binary classification, like say bad and good, but that's the main idea, because when you introduce MLOps to the company, you're starting with a small steps. It's not like, okay, this is MLOps, you should follow it. And trust me, nobody will follow it. But you show in by doing with the small steps. Look, instead of repeating this code here and here and here and here, we can extract this code and make a nice library for it for internal usage. Then you see there is completely no documentations about how these features were engineered. Let's add these features here. Hey, take a look. I will show you how it's easy to use MLflow and make sure that all your runs are saved, although you run everything locally. So all these steps could be incorporated in the journey. And as a data scientist, you can learn from it as well. And the best practices will be shared during the lesson 4. So during the whole bootcamp, I will give you piece by piece a small bits of machine learning engineering wisdom, and then we will see where it leads you to actually.
Okay, that's all the questions we have. And for the audience, if you have any questions, drop it in now. It's a good time.
Yeah, probably I see we're already behind the schedule. So actually what we can do, we can wait for 2 minutes more, because I know there is some lag in the streaming. But for the rest, for those who are parts of the bootcamps, if you have all these questions, you can drop them on Slack, or you can do it differently. If you want to wait, you can just wait and see how we will go step by step. But if you have questions related to home assignments, or if you have issues with installations, if you're not capable of finding something, after this event on Slack, we're gonna publish the split between teams, so you will know to which team you belong to, and mentors, so you'll know who is your mentor. And your mentor will be your guiding North Star during the whole project. So if you have any issues with installations, you can address there. Also, keep in mind that we and mentors, we all doing it on a voluntary basis. So let's make sure that our mentors are not overloaded as well. But at the same time, I don't want to discourage you of asking questions, but just be cautious and humble, because mentors are also people who has their full-time job and they just do it because they want to share their knowledge and they want to help you to be a better Python coder.
Okay, so we have no more questions in the chat. I think we can close, and
yeah.
Thank you all so much for watching, and see you at the next lesson.